Let's take a look at number 10 in section 5.6. We're given that a particle moves in a straight line with a given velocity. V of t is 16t to the negative 2 minus 1. So this is the same thing as 16 divided by t squared minus 1. And again, your velocity might be slightly different formula, but very similar. And this is that's meters per second. So the velocity units are meters per second. Find the displacement and the distance traveled over the time interval from 1/2 to 11. So from 1/2 second to 11 seconds. Again, t is the elapsed time in seconds. And important, you're going to use symbolic notation and fractions where needed. So we have to give the result as a exact value as a fraction. So first of all, if you recall, displacement is the net change in position. So the integral of the rate of change is the net change. So we simply integrate the velocity function from 1/2 to 11. So here's velocity function, and I'll use the fundamental theorem of calculus part 1 to do that. The antiderivative of 16 t to the negative 2, well, 16, I'll pull that out. T to the negative 2, I add 1 to negative 2, getting negative 1 divided by negative 1. Minus the antiderivative of 1 is t. So cleaning this up a little bit, 16 divided by negative 1 is negative 16, and then t to the negative 1 is 1 over t, so negative 16 divided by t, or negative 16 over t. Is how that simplifies, minus t. So just cleaning it up a little bit. Now I plug in 11, right? Evaluate this at 11, evaluate it at 1/2, and subtract. So at 11, I get negative 16/11 minus 11, minus plugging in 1/2. Well, 16 divided by 1/2 is 16 times 2, which is 32. So I get negative 32 minus t is 1/2 again, and we get this. And so if you do this simplification, then you need a common denominator over here, right? Which will be 11 in this case. So 11 is 121 over 11. So negative 16 minus 121 is negative 137 elevenths. And here I need a common denominator of 2. So I've got negative, 64 halves minus 1/2 is negative 65 halves. And then to subtract, of course, minus a negative is positive, but we'll need a common denominator between 2 and 11 now, which is 22. So multiply top and bottom of this one by 2. 2 times 137 is 274, so that's negative 274 over 22. Here I multiply by 11 top and bottom. 11 times 65 is 715 over 22. And notice again, minus a negative makes that plus. And so I get 441 over 22, which is about 20. Remember, the units here are going to be meters, right? The rate was meters per second. And so this is displacement. And essentially, starting at 1/2 second, by the time we get to 11 seconds, the object is about 20 meters to the right of where it initially started. Okay, so if it started, at this location here along that line, then suppose this is 20 meters between my fingers, it would now be here. It doesn't mean it just went from here to here. It could have went, this way and then back this way and then back this way and then finally stopped there by 11 seconds. We don't know. So displacement is not distance traveled, right? If it just went from here to here, then that would be the distance traveled, but we don't know if it's kind of moved back and forth. And in fact, it does. It moves to the left and to the right. And we'll see why. Because in the second part, distance traveled, therefore, I want the absolute value, right, of the velocity function. Because basically the velocity, positive velocity means I'm moving to the right. Negative velocity means I'm moving to the left. And so moving to the left, we don't want to take away, distance. We want to add that distance. So we just want to take the absolute value of it. So a little analysis, basically, when's our velocity function equal to 0? Well, that's an easy equation to solve. I just add 1 to both sides, multiply both sides by t squared, and then, of course, therefore, t is what? Plus or minus the root, plus or minus root 16, which is 4. And so I'm only interested from 1/2 to 11, so I'll only look at the positive side. There's a vertical asymptote for our velocity at 0, so let's just look at positive time anyways. It only makes sense. So for everything greater than 0, we know at 4 that it's 0. This is a sign of my velocity. I just put undefined at 0. If I pick any number between 0 and 4 and plug it into the velocity function, here it is. Of course, 16 t to the negative 2 is 16 divided by t squared. So if I take 1, for instance, what's the velocity at 1 second? Well, 16 divided by 1 squared is 16, minus 1 is 15. So at 1 second, you're going 15 meters per second. But the bottom line is the velocity is always positive between 0 and 4. And then after 4, like at 5 seconds, if I plug in 5 seconds, 16, 5 squared is 25, 16 25ths minus 1. Well, that's negative 9 25ths. So the velocity is negative for values of time greater than 4. Basically, the object is moving to the right from 0 to 4 seconds, and then from the left from 4 seconds on. So what that means is from 1/2 to 4 seconds, the velocity is positive. So the absolute value is just the function itself. From 4 to 11 seconds, though, the velocity is negative. So notice I need to multiply by a negative for that integral, right, in order to get that to be positive. All right, I want the actual distance traveled. So as we're moving to the left, I multiply it by a negative, which if I distribute that negative sign, gives me that. Now I just find the antiderivative, evaluate each one, right? I've got the antiderivative. And notice the antiderivative of 1, this one over here, is just going to be negative 1 times the antiderivative here, right? So it's negative difference. And this is the same antiderivative here that we had above. And so now we can evaluate this, plug in 4, plug in 1/2, plug in 11, plug in 4, and a lot of stuff going on here. I actually use this nice little button on the calculator, the convert to fractions buttons, in order to get in order to get the exact fractions here and add those together, but very similar to what we did above. So notice the total displacement is 637 divided by 22. Let me just see what that is. 637 divided by 22 is about 28.9, almost 29 meters. So that was the total travel, 20, even though we end up 20 meters where we were at 11 seconds, we're 20 meters to the right of where we were at a 1/2 a second. The total displacement was closer to 29 meters. Okay, I hope this is helpful on this one, and if not, let me know.